Okay, so I said like a few minutes ago, first of all, I want to summarize the strain transformation, but not whole chapter, just only half of the chapter, or general meaning of the strain transformation. And I want to make solve maybe one or maybe two examples in this lecture. Okay, in this lesson. What is the meaning of strain transformation? The geometrical of strain transformation like this. First of all, you know, if beam, I think I can make a slideshow. It's much better. Like, for example, if you want to geometrical measure. I'm sorry. I think that also my voice is available in this slide. I can like this. Stop. I think that when I hearing my voice like this. Okay, never mind. I think that I give up presenting my slideshow. Okay. If being first of all like this position, if deformed like this, okay, our infinitely small element does not remain cube like this shape. There's another kind of deformation occur. Do you know what is the meaning of epsilon gamma meaning? Do you know this? I think maybe you forget this. Epsilon is the longitudinal elongation or longitudinal length change. Maybe elongation or shortening, it doesn't matter. Okay. So Z meaning that for Z direction, X meaning that for X direction, Y meaning that for Y direction. So these cube can elongate or shorten it, can change their length both for triangles, and we unit length change we define as a epsilon. Okay, maybe you remember that the formulation. Where's my point paint? Like gamma is equal to E times. You remember that? I'm talking about this value. Do you remember this formulation? I think you remember. Okay. So also we are wondering that if different orientation, okay, also this is a 3D case. For the 2D case, we are not considered about the epsilon z, gamma xy, and gamma yz, okay, values, or this becomes 0. So just we are considering the epsilon x, epsilon y, and gamma xy for plane strain, okay. So similarly, we have a same question for stress transformation. With different orientation, we have a what is our epsilon x and epsilon y and gamma xy changes. If it's remains same, or we will get different values. Similarly, stress transformation, we will get the different value, I can say. Okay. So what is the after? I don't want to go into proof, but proof is a little bit different from the stress transformation. For stress transformation, we are using the equilibrium equation, but for strain transformation, we are using the geometrical properties. Okay, by using geometrical properties, also you can look at the book. For example, I want to show, like, I need to show the proof like this. Yes, here we go. Like, they are showing that how is it changes, okay, by using this figure. Can you see clearly? Very well. Like this, okay. You can see sine, cosine theory. Always we are using the geometry, okay. By using this relationship, okay, we are obtaining this equation. I don't want to go in detail, okay, because we are not responsible, but I can say that by using geometry we can get these equations. When you look at the equation, do you think it is similar to stress transformation? Do you think? Do you remember the stress transformation formulation? Maybe I can open for you. The stress transformation formulation. Yes, this is my formulation. This is stress transformation formulation. These three equations. These are the strain transformation. Is it similar? Silence again. 1, 2, 3, 4, 5. I think this is similar. You can see just sigma x plus sigma y divided by 2. In here, sigma epsilon x epsilon y divided by 2. Almost equation same. Just only one difference. Maybe you recognize or you didn't recognize. Just in this equation, I'm sorry. In this equation, when you see tau xy, for example, we use epsilon xy, epsilon xy, epsilon y for gamma y in the equation, but we don't use epsilon gamma xy for tau xy. We are using the half of the gamma xy. So gamma xy divided by 2, just only difference between two equations. So we can, if you remember, if you memorize the stress transformation equation, you don't need to memorize the strain transformation equation because these are almost same. Just only you remember that I should write gamma xy divided by 2 for tau xy. Just it. Okay. Do you have any question for this part? Okay. The formulation is same, so everything is become same for strain transformation. So not big deal. There's not big deal for doing the stress transformation. Maybe the repeating procedure of the stress transformation, it seems to be like that. So clear. Okay. I'm continue. So I did this example. I think I can solve also for maximum in-plane and shear principle and maximum in-plane strain formulation is also similar. You remember that two principal stresses. Where is it? My principal stress formulation. Where is it? Yes, this one. For example, principal stress formulation is, where is it? I cannot find this one. Yeah, this one. Just sigma 1, 2 is equal to sigma x, sigma y divided by 2 minus plus or minus in square root. This formulation, you can see this formulation is similar. Similarly, from first equation transformation, we should write gamma xy divided by 2 for tau xy. Okay? So everything is similar for stress transformation equation. Again, orientation, we will write to 1/2 tangent gamma xy epsilon x minus epsilon y. For example, if the orientation angle, we can remember that we are using the divided by 2. In divided by 2 disappear, we just only write gamma xy divided by epsilon x minus epsilon y for principal stress transformation formulation. You can see. Okay. So everything is same. Just I want to ask a question. If I ask a question for stress transformation in the exam or homework, okay, which method do you want to use? Which method do you prefer to calculate to solve the example? The method options is, first option is the using directly the equation. Second option is the using the Moore circle theory. Which one? Do you prefer more circle or equation? This equation. No one can. Ahmed,
I prefer this equation.
Equation.
Yes.
Okay, straightforward. You know, I have an equation. Write this. Is anyone guess? Is anyone want to use like to use the Mohr circle theory for stress transformation? Do you like or doesn't like? No one like Mohr circle theory? Who
I
said?
haven't, sir.
Mohr circle. Ahmed. Ahmed preferred Mohr circle. Okay. So just my question is, can I use the Mohr circle for strength transformation? Yes, definitely we can use. Similarly, we can use the Mohr circle for plane strain. Okay, strategy is similar. Remember that just only we will write when I'm picking for the tau xy, we are choosing for gamma xy divided by 2 for points. Okay, so you remember that for x direction we are using the epsilon, sorry, gamma. For y direction we are using the sigma, tau, sorry. Okay. For strain transformation, for x angle we are using the epsilon. For y direction we are using the gamma over 2. Okay, gamma divided by 2, not gamma. Don't forget. Okay, y direction should be gamma divided by 2. If you use this strategy, you can easily use the Mohr circle theory. Its strategy is completely same with this stress transformation. Okay. Who said prefer to use the equation? Equation, if anyone guessed want to use the equation is straightforward. Okay, write the values, get the result. But you know, Mohr circle is not related to equation, but solution strategy seems to be little bit more simple than the equation, because if I were you, I prefer the Mohr circle theory. But you know, also equation is the just guaranteed way. You know, if you do not make any computational mistake, you can get the exact result. But in Mohr circle, you can make a mistake. So you prefer to you know, guaranteed way. Okay, so Mohr circle on plane strain. Okay, let's do an example. Okay, I don't want to use example on this slide. I prefer to use the example on Hibeler book. Okay, just you choose for me, or if you say, hocam, you can choose any equation for us. I can, the solutions available like this. Examples starting from 10.1 to like 14. Which one do you prefer? Say a number from 1 to 21. Who says, say it for me or write it for me? Say a number. Ben mi söyleyeyim? 5. Okay. Thank you. And don't look at the figure. Figure is not related to, it's not important for solving questions. So just because these values are enough for us. To state of strains at point gear tooth has components epsilon x is 520 10 to the power minus 6. Epsilon y is minus 760 10 to the power minus 6. Gamma xy is the minus 750 10 to the power minus 6. Use strain transformation equation, determine the principal strains, okay, and find the maximum in plane shear strain and average normal strain. Okay, average normal strain is easy. Okay, we can find in the. So most of you prefer to equation. Okay, so I want to use the first of all doing the equation. Okay, in the example I want to use the word. Okay, I didn't prepare my cell phone for showing my whiteboard, therefore I have to use my word for solving example. It will take time, but it doesn't matter. First of all, insert. Where's my equation? Yes, here we go. Just, do you have any experience about equation editor? Do you know this in Word?
Yes, hocam.
Did you make any practice? No one? Yapmadınız mı hiç? Equation editor.
I know.
You know this. If I can increase to, I think that this size is enough. I think that epsilon x is equal to, sorry, 550. I don't want to 10 to the power minus 6. Okay, I will write to later. Okay. On my equal to minus, okay, also, and also gamma xy. Is gamma available in the standard matrix formulation? Yes, very well. That's my gamma, yes. Gamma xy is equal to 750, I remember that. 750. Okay, so I need to look at the equation. I don't need to memorize because it's the equation I will give in the exam also online. So where's my general formulation? I'm looking for the plane strain. Yes, very well. This equation is available. So I copy and paste in here. Okay. Yes. Okay. So I write two values instead of the epsilon x. Okay. Epsilon y. I need to write to 750. I do in here. Okay, right. 750 but minus, so it should be positive, minus, minus, positive. And gamma xy is minus 75. So minus is not important. Minus is not important in our function. Okay. So first of all, I want to compute. Okay. We should see. Copy. This is 120 minus. This one is 640 minus minus. equation is minus 20 plus square root sorry. Okay. Also, I should write the 10th power in here. Okay. So 10th power minus 6. I need to write 2 cross in here. There's my plus. That's very well. Okay. Is it easy? Straightforward. Put the equation and compute to, solve the equation. It's very easy, straightforward. I think that. Do you have any question? I think that you have no question for this. Okay. Also, I should write where's my tau xy maximum? No, drastic strain formulation. Where is it my tau maximum? Yes, this one. Okay. So I can write tau xy. Sorry. 'This is my first solution. This is my second solution. I can do this one, which is 66. Okay. So let me explain. It's equal to 1483.54. So I should write 10 power minus 6. Let control. So we find the in-plane plane strains. Okay. Epsilon 1, epsilon 2. B is maximum in-plane shear strain. Okay. What about the average normal strain? Do you want to anyone guess? Hocam, what is the meaning of the average normal strain? Buse, Mert, Ahmet. Just guess for me. Oh, Mohammed, welcome. Umut. What is the meaning of the average normal strain? Okay, no one guess. Okay, I will guess for you. Okay. Can I copy for this? No. The prop. I think I should copy, make a copy, but right? Yes, copy text. Just average normal strain is meaning that this also equal to this. Also equal to this. Okay. I'm sorry, let me check. Average normal strain should be epsilon 1, epsilon 2. Let me check. Okay. I made a mistake, I think that. Not 60. Sorry. Do you want anyone? Does anyone want to ask a question for this example? It is very straightforward, isn't it? They're signing. Okay. Second, this is the first option, equation option. Okay. Let's also, I want to solve this example by using the Moore circle theory. Okay. Moore circle strategy. Let me 5 seconds to prepare my whiteboard. Okay. To drawing Moore circle. Can you see the whiteboard clearly? I think.
Yes, we can see clearly.
Okay. Very well. So I want to use the Moore circle. I need to look at two system. First of all, I need to write the epsilon x, and yes, this one's okay. Epsilon x is equal to 520. Epsilon y is equal to minus 760, and tau xy is equal to minus 750. Okay. We will use a similar strategy for strain transformation for drawing Moore circle. Just only forget to we will use gamma xy over 2 for tau xy. Okay. So maybe remember for Moore circle. Remember for first point is 0.1 in stress transformation. We are using this sigma x minus tau xy. So my strain transformation, I will use the epsilon x of 0.1 minus gamma xy divided by 2 for y coordinate for 0.1. For 0.2, okay, first coordinate is a1, epsilon y, second one is gamma xy divided by 2. Okay, my second point. Now I am ready to locate these points, my coordinate system. This is gamma xy divided by 2. This one is epsilon. Yes, not gamma xy. I think that I can write the gamma y, not this more general definition. Okay. First point is, so epsilon is equal to 520. Gamma xy divided by is minus positive, so this is positive 375. This one is minus 760. This one is minus 371. Okay, this is my coordinates. Also, I want to write the minus 10 to the power minus 6 cross 10 to the power minus 6. Okay, I want to pick first point is 500, 1, 2, 3, 4. No, I can't use a smaller part. 7 is so big number. I'm comparing 1, 2, 3, 4, 5, like this. Okay, this is this coordinate. My coordinate is 3, 5, 1, 2, 3, and this is my first point. Okay. Second point is 1, 2, 3, 4, 5, 6, 7, like this, 760 point minus, and this is it, minus 5, 1, 2, 3, 4, so this point, okay. So I merge these 2 points with line, okay. This is the centroid, okay. So you know this is the 520. This is minus 760. So average of this minus 120. Okay. And I want to use the more circle. This big circle. Okay. So which triangle do you want to use? This triangle or this triangle? I think you can use this triangle. Okay. This triangle, this length is, I think that 640, 520 plus 120, okay, 640. Also, you remember that this length is 375. I don't have enough space for calculating the Pythagoras, diagonal length. I want to use different space. I want to use this one. Okay, this is my triangle. This is 640. This is 375. Okay. So, I want to use R. R is equal to square root. Okay. 375 squared plus 640 squared is equal to, I don't have a calculator, but I think I calculated this. Yes. I already calculated this value. This value is equal to 741.77. Okay. I can get this part. So you can see in R is equal to, R is equal to radius of these, I'm sorry, not this one. Radius of the more circle, okay? So this is also R is equal to maximum divided by 2 is equal to R, because you remember that. So I say that this y direction represents gamma divided by 2. So this is the R is the tau maximum divided by 2. So tau maximum divided by 2 is R. So tau maximum is 2R. So this equal to, what is this? 1483.8 5, 4. Okay. Also, don't forget, right? 10 to the power minus 6. Do you have any question for calculating the Tomax? Do you have any question?
No question.
Okay, I think it is very clear. Okay. So I want to contribute to epsilon 1. This is the epsilon 1. This is the epsilon 2. Okay. You can see the graphically. Okay. Epsilon 1 is equal to, this is the centroid, minus 120 plus R value. Okay. Epsilon 2 is equal to minus 120 minus R value. We already calculated to R value, you remember that? It's equal to 741.77, 741.77. So if I compute this, I obtain, this is the 621.77. This is the minus 861.77. Okay. So also don't forget, right? Then power minus 6. Okay. Also, average of the train is, you can see in graphic, the centroid of the Mohr circle. Also, average is minus 120 and power minus 6. Okay. Do you have any question for whole solution strategy of the Mohr circle? I think we can compare with our result. I think we get the same results. Yes, correct. Yes, correct. And correct. Yes. This is the Mohr circle strategy. You can see, hocam, it seems to be very simple, hocam. We can easily solve this example in the exam because it's straightforward. Put the equation or draw with Mohr circle. I think you can realize that. Maybe, did you look at the homework question? No one can look at the homework question, I think that. Okay, I prefer to combine with the strain transformation with the stress strain transformation. What is the meaning of stress strain transformation? For example, I can prefer to not, I'm opening the chapter 9. Where's my chapter 10? Yes, like this. Where is it, my Mohr circle? Maximum. Yes, this one. I want to combine with maximum strengths by shearing rosettes. First of all, combine with, or I prefer to use the stress-strain relationship formulation. Maybe I can show you where is my formulation. This one. I can place the part like this. Okay. You know, for example, I can give sigma x, sigma y, and sigma z values. By using these values, you are calculating the epsilon x, epsilon y, epsilon z. Then you can compute to epsilon 1 and epsilon 2 or tau max in plane to my first solution strategy. Okay. Second, my questions asking strategy is please look at chapter 10.1 in my video, okay, offline video. So we different orientation, how we can compute to epsilon x, epsilon y, and epsilon z by using formulations. Okay, this is a special conditions. Okay. Then after that, I can ask you epsilon 1 and epsilon 2. So I need to combine two information stress-strain transformation and measurement of the strains by shear rosettes or stress-strain relationship. Okay, my question strategy like this in the exam. Don't forget this. Okay, I don't want to ask directly stress-strain transformation. I think this is enough for this week. Next week, maybe I can ask you one of these parts, okay, for strain transformation. Do you have any question?
No question.
No question.
Okay.
No questions.
Thank you so much for coming and attending, okay. First of all, I want to say that I thought that like 2 weeks ago, okay, only 8 people attending to my online meeting, which is very low, I was thinking. Then I realized that only 8 or 9 people taking my course in total. So it is almost 100% attending level in my meeting. It's very good for me. Thank you for attending for me online meeting. Thank you so much, I want to say. I hope you will get the good results in the exam. If you continue attending online meeting and watching my offline videos, I think you don't have any trouble to understand chapters. Okay, I can't. This is end of to my lecture. Okay.
Thank you for your effort.
Thank you so much. See you next week. Is anyone want to say something before my ending meeting?
No.
Sir, can I ask another question? When is this 40 or the matrix lesson?
Yeah, like say, yeah, matrix structural analysis. I think that you are asking that, Ahmet, isn't it?
Yes.
Yeah, it's same time. Okay. Yeah, last week there's a holiday available in last week. Therefore, I cannot be available in my office, and I can't make Teams platform. I don't have any Teams platform outside. Therefore, I prefer to cancel to online meeting. Instead of online meeting, I put the offline video for matrix structural analysis. But for this week, there is no obstacle. We will do on 2 p.m. today.
Okay, sir. Thank you.
Okay, see you on 2 p.m. Arkadaşlar, I am ending my recording.